Elon Musk didn't want a factory. He wanted a giant robot. A machine so intelligent it could build millions of cars faster than any human system ever could. What used to take 70 parts and hundreds of robots, Tesla replaced with one earth-shaking machine. This was the moment manufacturing changed forever. Imagine a factory that can see, think, and learn. Tesla isn't just building cars. It's building the first living machine of industry.
The analogy is born. Our story begins not with blueprints, but with a metaphor. Elon Musk, frustrated by the slow, capital-intensive pace of traditional auto manufacturing, famously derided conventional car plants as lumbering barns. In his mind, a factory shouldn't be a static container where work happens, it should be a product itself, the ultimate machine. The seed is planted. What if the factory were a giant, intelligent, ever-evolving robot? Its sole purpose, to create other machines, cars, with maximum speed and minimum waste. This isn't just an aesthetic choice, it's a fundamental reimagining of manufacturing as a dynamic, unified organism. First principles for factories. To build this robot, Musk applies his first principles reasoning. He strips car manufacturing down to its atomic truths: you need to shape metal, join parts, add propulsion, and control systems. Every convention, the mile-long serpentine assembly line, the thousands of individual parts, the reliance on hundreds of suppliers, is questioned. The goal becomes architecting a system where the flow of materials and information is as elegant and direct as the circuitry on a silicon chip. The giant robot's body plan must obey the laws of physics and logic, not the legacy of the 20th century. The Giga Press revelation, the giant's hand. The first physical manifestation of this philosophy is the Giga Press. In a traditional factory, a car's rear underbody might be made from 70-plus individual stamped steel pieces, painstakingly welded together by dozens of robots. The Giga Press is the giant robot's mighty hand. It takes a molten alloy soup of aluminum, and in one earth-shaking, 6,000-ton squeeze, prints the entire complex structure as a single piece. This one action eliminates hundreds of robots, reduces weight, improves durability, and turns a 2-hour welding process into a 90-second casting. It's a brute force application of elegance. The body in white, simplified, the skeleton. With giant castings for the front and rear, the car's skeleton, body in white, is no longer a fragile 3D puzzle. It becomes more like connecting a few simple, massive Lego bricks. In the new Unboxed system, these castings are simply joined with structural battery packs, forming the core chassis in a handful of steps. This simplification is the robot strengthening its own skeletal frame, making it sturdier, lighter, and drastically easier and faster to assemble. The complexity is designed out at the part level, not managed on the line. Conveyors as tendons and arteries. Forget the simple conveyor belt. In Tesla's giant robot, the car bodies are moved, lifted, tilted, and rotated on a sophisticated system of programmable platforms and lifts. These are the robot's tendons and arteries. They don't just move the product, they actively position it for the next task, optimizing the ergonomics for both machines and humans. They can change pace, route, and orientation based on real-time demands, giving the factory a fluid, almost biomechanical sense of motion. The digital twin, the factory's brain and consciousness. This is the true secret. Every physical element in the factory, every Giga Press, every welding robot, every autonomous cart, has a perfect, live digital duplicate in a virtual simulation. This digital twin is the giant robot's brain and central nervous system. It runs continuous simulations, predicting bottlenecks, testing new robot dance moves, and optimizing flow before any physical change is made. It knows the status of every component in real time, allowing for a God's eye view of the entire organism. The Unboxed Assembly Line, parallel processing. The traditional assembly line is a linear, sequential spine. Tesla's new, unboxed process is the giant robot using parallel processing. Instead of one long line, the car is built in dedicated, static zones, for interior, powertrain, side panels, simultaneously, like a robot using multiple arms to work on different parts of a project at once. These large subassemblies then converge and are integrated in a final marriage station. This slashes the factory's footprint, its body size, and cuts final assembly time by over 30%. A sea of sensors, the robot senses. The factory floor is bathed in perception. High-resolution cameras scan every weld seam. LiDARs map the position of parts to sub-millimeter precision. Spectrometers analyze paint quality. Microphones listen for the abnormal whine of a failing bearing. This constant, omnipresent stream of data is the giant robot's sight, touch, and hearing. Nothing happens without being observed, measured, and logged. Self-diagnosing machines, the immune system. An individual welding robot doesn't just fail. It sends an alert that its servo motor is drawing 5% more current than historical baseline, predicting a failure in 72 hours. This is the cellular-level immune response. Maintenance is scheduled proactively. Replacement parts are ordered automatically. The system anticipates and neutralizes threats before they cause downtime, giving the giant robot a form of regenerative health. The autonomous logistics spine, the circulatory system. Parts don't arrive in piles. A silent army of autonomous guided vehicles, AGVs, and smart, overhead delivery systems act as red and white blood cells. They navigate optimized paths, delivering exactly one battery pack, one set of seats, or one windshield to the precise point of need, at the exact second it's needed. This just-in-time, just-in-sequence flow is choreographed by the central brain, ensuring the robot's muscles are never starved of nutrients. The data diet, food for growth. Every sensory input, every completed cycle, every stoppage is data. This data is the giant robot's primary fuel. Machine learning algorithms feast on it, finding patterns invisible to humans, a slight vibration at station B that correlates with a paint defect at station F. The robot doesn't just work, it learns from every action, continuously refining its own internal model of optimal performance. Overnight software updates, rewiring the brain. Improvement doesn't always require a wrench. Often, it requires a line of code. An engineer can tweak an algorithm in the digital twin and, during the next downtime shift, push a software update to the entire factory. Overnight, the paths of AGVs are smoothed, robot movements are accelerated by 2%, and inspection criteria are tightened. The giant robot wakes up smarter, faster, and more precise, just like a Tesla car receiving an autopilot update. Iterating itself, generational evolution. Giga Berlin and Giga Texas are not copies of Fremont. They are version 2.0 and 3.0 of the giant robot. Lessons learned in data from Shanghai, about humidity affecting adhesives, or local logistics patterns, are baked into the DNA of the next factory. Each new body is born more advanced, inheriting the collective knowledge of its predecessors. The factory itself is in a state of perpetual beta. The alchemy of speed, the prime directive. The giant robot's core programming is to minimize cycle time, the time it takes to perform one complete operation. Shaving 5 seconds off a door panel installation might require a complete resequencing of tools and a new robot dance. This relentless, granular focus on speed is the robot's heartbeat, pushing every subsystem to operate at the very edge of physical possibility. Vertical integration as muscle fiber, direct neural control. By making its own battery cells, seats, castings, and software, Tesla isn't just cutting costs. It's giving the giant robot direct neural control over its own muscle fibers. There's no lag from ordering parts from an external supplier, the brain commands the battery cell muscle directly, ensuring perfect synchronization and rapid adaptation. The organism becomes more unified, more responsive. The closed loop, the robot's metabolism. Scrap aluminum from casting isn't waste, it's fed back into the furnace. Water is treated and recycled. On-site solar and megapacks power the operation. This is the giant robot's sustainable metabolism. It strives to be a self-contained ecosystem, minimizing its waste output and environmental footprint, operating with efficient, circular logic. Humans as programmers, not welders, the engineers and trainers. The human role transforms from manual laborer to systems biologist and trainer. People design the robot's algorithms, analyze its performance data, program its movements, and intervene for complex, novel tasks. They are the creators, philosophers, and coaches of the giant robot, focusing on higher-order thinking while the robot handles deterministic, repetitive motion. The dance of safety, creating symbiosis. With 10-ton castings flying and robots whirring, safety is paramount. The factory uses geofencing, light curtains, and sensors to create virtual force fields. When a human steps into a zone, nearby robots slow down or stop, a graceful, respectful dance. The giant robot is aware of its fragile human collaborators and is programmed above all else to protect them. The relentless quest, embracing the struggle. The story isn't one of perfection. The giant robot is a mad, ambitious, sometimes chaotic experiment. It has bugs. It breaks down. The Cybertruck's radical design nearly broke the machine, requiring painful, iterative retooling. But this is the essence of the story: the giant robot is built to endure this struggle. Its core function is to learn from failure, reconfigure, and adapt. The quest for manufacturing, alien dreadnought, technology is a perpetual journey, not a destination. A prototype for Earth, training for Mars. Finally, we zoom out to the cosmic scale. The ultimate, audacious vision is that these terrestrial giant robots are prototypes and trainers for extraterrestrial industry. If you can create a self-optimizing, highly automated, resource-efficient factory that can build anything from a car to a battery to a robot, you hold the key to building a settlement on Mars. The Tesla factory, therefore, is the most important product. It's the machine that will learn to build the machines that will build a new world. It's not just a car plant, it's a gymnasium where our industrial future is training for the ultimate off-world mission.